Alright, we're going to do the sample test for the 102 exam coming this Friday. Here's the sample test. Says tossing a coin and rolling a regular six-sided die. So let's do this. So I could toss the coin and it could go heads or tails. And then I'm going to throw a six-sided die. And that could come out to be 1, 2, 3, 4, 5, or a 6 with a head, or 1, 2, 3, 4, 5, or 6 with a tail. Now, if I wanted to list all the outcomes, head with a 1, head with a 2, head with a 3, heads with a 4, heads with a 5, heads with a 6, tails with a 1, tails with a 2, tails with a 3, tails with a 4, tails with a 5, and tails with a 6. Draw a tree diagram. Probability of A. A was a head showing. There's heads in 1, 2, 3, 4, 5, 6. There's heads in 1, 2, 3, 4, 5, 6 branches. So the probability of a head is 6 out of the 12 possibilities, or 1/2. Determine the probability of A and B. B is getting an even number. 1, 2, 3, 4, 5, 6 have even numbers. 6 have heads, but I have to get heads and an even. So that means I'd have to be just with that 2, heads 4, and heads 6. 3 out of 12, which is 1/4. Probability of A or B. Well, all 6 of those have at least a head, or show an even. That would be, don't want to need to count these evens again because I count them with a head. So 6 plus evens down here are 1, 2, 3. So that's 9 out of 12. Determine the odds of not getting A and B. Odds of not getting A and B. So the odds, what's the probability of getting A and B was 3 out of 12. So not getting A and B would be 9 out of 12. That's the probability. So the odds is for not getting it would be, how many ways to not get it? 9 out of 12. To how many ways there are to get it, which was 3 out of 12. The 12s cancel, and so we get 9 out of 3, or 3 to 1 odds. Probability of A given B. So that means we count up how many are in B, which is even. Well, we did that up. No, we didn't do show an even. 1, 2, 3, 4, 5, 6. Of those 6 outcomes that are even, how many include A? A was a head. A head with an even is 1, 2, 3 of those 6. So the probability of A given B is 3/6 or 1/2. To check independence between A and B, I can either check, see what the probability of A is, and compare it to the probability of A given B, if they're equal, independent. Or I can do the probability of B and compare it to the probability of B given A. Well, since we just did the probability of A given B and got 1/2, and we did the probability of A, which was 1/2, the probability of A and the probability of A after B has happened didn't change. B didn't change the probability of A. It's still 1/2, so they are independent. That's one. Now, I was kind of crowded there. I want you to know that when I give you the test, I'm going to shrink this way down and give you a lot more room to work. Okay? So it might be more pages, but I wanted to conserve paper when I wrote this out. So I expected you to work it on your own paper. Determine the following probabilities and state whether theoretical, relative, experimental, relative frequency or experimental, or subjective. Drawing a king from on a single draw from a standard deck of cards. Well, that's 4 kings out of the 52 cards. And we got this because we can count all the possibilities and we can theorize that they're equally likely. This is the theoretical. The winter will be the snowiest in the last decade. Doesn't sound like it's based on any statistics. It's just kind of what somebody is thinking, unless it's the weatherman. So that sounds very subjective. The next big lottery winner is below the poverty level. If 13% of what's the probability the next big lottery winner is below the poverty level? If 13% of the last 100 big lottery winners had incomes above the poverty. So we're going to base it on some statistics that we already have. That's from collected data, so that's relative frequency. And so that's 2. 3. A restaurant, Simply Burgers, keeps its business simple by serving only burgers that always have their special sauce, lettuce, and onions. So there's no choices there. If you're going to have a burger, you have a burger with the sauce, lettuce, and onion. They do allow you to add either tomato, pickle, and or cheese. So our first choices are about the tomato, pickle, and or cheese. Now, is this a case where you get only one of them? It's not, and so you could get one of them, or 2 of them, or 3 of them. And early on, when we talked about sandwich condiments, we decided that you then have to do tomato or no tomato. Then it was pickle or no pickle, pickle or no pickle, and then you could choose cheese or not cheese, cheese or not cheese, cheese or not cheese, and cheese or not cheese. And then the burger always comes with one of the three. So it's not a choice of doing one or two or three or none. And so we can now go, it's going to be the choices are fries, salad, or pie. And I'll do that on each one of these. Fry, salad, pie, 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 fry, salad, pie. So I had 2 choices on the tomatoes times 2 choices on the pickles times 2 choices on the cheese. Have it or not, have it or not, have it or not. And then 3 choices on the sides. Makes 2 times 2 times 2 is 8 times 3 is 24 options. Make a tree diagram. We've done that. How many possible burger meal combinations are there to choose from if you consider the choices of adding or not adding tomato, pickle and or cheese, and you get one of the sides? 24. If a random burger meal is selected, what is the probability that the meal has a tomato or a salad as a part of the meal? We can figure out the probability it has a tomato, 50%, 0.5, 12 out of 24. Probability it has a salad, that's 1/3, or 8 out of 24. We could add those, but then we'd have to subtract off any where we counted tomato and a salad. Or we can do count up all the meals that have tomatoes. Well, that tomato was our first choice. That's half of them had a tomato on it. Half of the 24 is 12. Plus, how many additional ones had salad? All these down here didn't have tomato. Salad was my middle one, so there's a salad on 4 down here. So 4 of these branches down here have salad, so 12 plus 4. And if I want probability, that's out of the 24. So it's 16 out of 24 for part C. That reduces to 8 goes in both of those, 2/3. And if a random meal is selected, what's the probability that the meal has a tomato or a salad part? We did that. What is the probability that there is at least one condiment? At least one condiment, that means there's only one branch that has one start of a branch that has no condiments. It ends up with 3 sides possible. So there's 3 branches that have a no condiment on the burger, and there isn't a salad. Oops, what's the probability that there's at least one condiment? So that would be all the rest of them. These 24, because only these 3 in the bottom don't have at least one condiment. So there's 21 out of the 24 that have at least one condiment, but there isn't a salad. So I'd have to throw out the ones with the salads, which is 7 of them. That leaves 2, 4, 6, 8, 10, 12, 14 of the 24 will have at least one condiment and no salad, which reduces the 7/12. Okay, number 5. Suppose that you are tossing two fair dice. So I'm going to choose a method to show the sample space. Now you could list all the outcomes. I like to do the grid. 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, 6. And so there's a method, so that's part A. Determine the probability of B. B is at least one die shows a 3 or a 4. Well, if I roll this dice as a 3, all of those would count as having a 3 on one of the dice. Or 4 would be the next one down. Or I could have a 3 on the other die, or a 4 on the other die. So there's B. What's the probability of B? 2, 4, and 6 is 10. Plus 6 is 16, 17, 18, 19, 20. So the probability of B is 20 out of, the dice has 36 possibilities. And you could reduce that. Not A. A was a sum of 5, and that's 4 and 1, 3 and 2, 2 and 3, 1 and 4. So there are 4 that are A. So there are 32, 4 from 36, 32 that are not A out of the 36. A and B, so it has to be in both. It has to have an X and a circle, and there are 4 out of the 36. A or B, that means it either has to have a circle on it, or an X, or both. Since all the circles are part of the X's, I don't want to count them twice, so all I have to do is count all the X's, which was 20 out of 36. A given B, so in the denominator, how many ways are there B? B was at least one die shows a 3 or 4. So there's 20 that have a dice showing 3 or 4. And how many of those, how many of those 20 have 3 or 4, and how many have A? 4. So that's the probability of A given B. Now the probability of B given A. How many ways are there to get A? And A was a sum of 5. There's 1, 2, 3, 4. So the denominator's 4. And how many ways are there to get B in that if you know you have an X, an A? Well, all 4 of them. Well, A is the circles. There are 4 of them. How many of the X's are in those circles? 4 out of 4, which is probability of 1. Are A and B independent? Let's see, we did A given B. We'd have to compare it to A. Or B given A, we'd have to compare it to B. Probability of B was 20 out of 36. B given A is 1, so they're not independent. So we're looking at, on that one we did the probability of B, which was 20 out of 36, and if it's independent, the probability of B would be the same even if we knew A happened. And the probability of B happening if we have A is the sum of 5. So if we're in the sum of 5, those 4, what's the probability we have B? It's guaranteed. Every one of them has B. So this is 4 out of given a sum of 5. Out of the 4, there are 4 that have B, which is 1. So the probability of B was this, but if we know A has happened, the probability B is 100%. These are not equal, so they are dependent. And that's page 1.